Alrighty, learning how to count. We learned this in preschool, how to count. But we're going to kind of firm up some little counting rules in probability. And the reason you have to learn how to count all over again in probability is that, oops, come on, stop it, stop, 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 stop. There we go. Stop. Don't be crazy. Um, come on. Go back to where you belong. There you go. The reason we want to relearn how to count in probability and use these rules for counting is that sometimes we have to figure out how many total outcomes there are, how many wanted outcomes there are, and we don't want to have to write down every single possible combination. Sometimes it's impossible to write down every single combination because there's so many of them. And sometimes it's just, just a little easier, a little faster. We could write them all down, but we'll find that we can calculate them just a little bit easier than we can write them. And sometimes when we try to write down every single outcome that could happen, we miss one or two. So if we know how many we needed to write down, it helps. So this is some counting theory that we're going to do here. And that branch of mathematics is called combinatorics. So let's do a little combinatorics. All right. So I got two events, A and B. If event A can happen M ways and B can happen N ways, then A and B can happen together M times N ways. What does she mean? Well, let's say you have 5 shirts and 3 pairs of jeans. The number of outfits I can make, and you have to wear a shirt and a pair of jeans for this outfit. You could have shirt number 1 with pair of jeans number 1, shirt number 2 with that pair of jeans, shirt number 3 with that pair of jeans, shirt number 4 with that pair of jeans, shirt number 5 with that pair of jeans. Or you could have shirt number 2 with sorry, not shirt number 2. Yeah. You can have shirt number 1 with pair of jeans number 2, shirt number 2 with pair of jeans number 2, so on and so on. How many possible outfits do you think I could make from those 5 shirts and 3 jeans? 15. 5 with jeans 1, 5 with jeans 2, 5 with jeans 3. Well, I could reason all that out and write everything down, or I could just take 5 times 3 and get the 15 that I was looking for, which is a little easier than writing down every single combination of your shirts and jeans. And it gets a little bit more complicated if you can't tell the difference between one pair of jeans and the other, but we'll stick to the simplest way of counting here. Okay. I've got my window in a bad place and it's not letting me move it. Okay. All right. So let's apply this to some probability problems. We're going to roll 3 dice. How many different outcomes are there on one die? And how many outcomes are on the second die? And the third? And if I roll all 3 of them together, it's 6 times 6 times 6. That's how many different outcomes there are when I roll 3 dice, and that is 6 to the 3rd power, which is 216. Okay? So I would not want to list all 216 of those possible rolls. So I have my little shortcut here. All right, how about if I just had 2 dice and 2 coins? For the 2 dice, for die number 1, there's 6 outcomes. For die number 2, there's 6 outcomes, so that's 36. For coin number 1, there's 2 outcomes. For coin number 2, there's 2 outcomes. So that's 6 times 6 times 2 times 2 is 144. There's 144 different ways I could have 2 dice and 2 coins. You know, we could have gotten a 2 and a 2 and a head and a head, or a 6 and a 5 and a head, a tail and a head. There's 144 different rolls and tosses here. What's the probability we get the one that is 6, 6, head, head? How many wanted outcomes are there? 1. Out of how many total possible outcomes? 144. Okay. You could have used the multiplication rule on this one. This one may just give it to you, give the answer a little faster. We use the multiplication rule on this. We might say 1 out of 6 times 1 out of 6 times 1 out of 2 times 1 out of 2, and I still get the 1 out of 144. Maybe just a little faster. Maybe not. Okay, so that's one counting that we're looking at. Another counting is the factorial rule. And if I've got n different items and I want to see how I can arrange all n of those items, the number of ways I can arrange them is in factorial. So if I have 5 numbers, let's do 1, 2, 3, 4, 5. How many different arrangements can I make of those numbers 1, 2, 3, 4, 5? Well, it could be 1, 2, 3, 4, 5. It could be 5, 3, 4, 2, 1. It could be 1, 3, 4, 5, 2. Oh, there's a bunch. Okay. If I want to arrange all 5 of those items, then I can count how many arrangements there are. There's 5 items, so it's 5 factorial. Do you remember what 5 factorial or 5 exclamation point means? Five times 4 times 3 times 2 times 1. All right, fairly easy to get that in your calculator. But I'll show you the button press. So to get 5 factorial in your calculator, you enter a 5, and then you hit the math key, and then you do the arrows over to PRB, and then which number is it? Number 4. And then I think you just hit enter when you get back. And what is 5 factorial? How much is it? 120. Okay, so there's 120 ways to arrange the numbers 1, 2, 3, 4, and 5. Okay. How many ways are there to order the numbers 1, 2, and 3?